everyone. I am Elise Kaplan. I'm the Vice President of Regulatory Affairs for the American Council on Renewable Energy. I want to welcome you to this very important presentation and discussion about how utilities, grid operators, regulators, all stakeholders can best deploy advanced transmission technologies, or what we're going to refer to them as ATTs, to boost capacity, improve flexibility, speed new energy integration. This discussion today will be centered on the newly released paper, Advanced Transmission Technologies Planning Guide, that was prepared by Quanta Technology in partnership with RMI, and we're very excited about this new resource. So we can go to the next slide. I'm going to do a quick word about ACOR and our strong interest in this topic. ACOR is a membership-based nonprofit organization focused on accelerating a clean energy economy. Both the expansion and optimization of the grid are high priorities as part of this mission. In cooperation with multiple partners, we have undertaken a number of activities to promote ATTs, including the release of several reports and papers, ATT playbooks, and a deeper dive into the ATT provisions in Order 1920. I'll highlight those quickly on the next couple of slides. And when you get these slides, there will be a link to those. So these are some of our playbooks. A huge shout out to both the WATT and AMP coalitions for working with us on these playbooks. And when I introduce the panelists, I'll introduce you to Julia, who's the Executive Director of the WATT Coalition. We're very pleased, as I said, to have this new resource from Quanta and RMI as an excellent addition to these guides, which show both the benefits of ATTs and multiple avenues for expanding their deployment in different forums. I'm now going to give you a quick logistical overview of the webinar. We will start with a presentation from Quanta. Before that, we'll have a quick opening from RMI, and then we're going to have a discussion with the panelists. We will share the slides and recording of the webinar afterwards. While you're listening to the discussion, you can see that there is a Q&A button at the bottom of your screen. Hopefully you're familiar with this, and you can enter your questions. We are going to leave a good amount of time at the end for Q&A. So before I introduce our awesome panelists, we have a two-part poll, kind of a get to know your audience better poll. So we can go to RMI's first slide and also pull that up. So the first one, we want to see, we've got almost 200 people now on the webinar. So we want to see who is represented here. So take a look at those categories. We'll give you a few seconds to check that off. And then another question after that is going to come up about which technology is the most excited about. To multitask, I am going to also introduce the panelists while you're doing the poll. First, we're going to have Dr. Sarah Toth-Kotwis, who is the Senior Associate at RMI's Electricity Program. And then the primary author of the report, Rahul Anilkumar, the Senior Director of Advanced Transmission Solutions at Quanta Technology. And then we will have additional input and commentary from David Quire, the Vice President and Chief Operating Officer at PPL Electric Utilities, and Julia Selker, Executive Director of the WATT Coalition. So let's see where we are on the polls. I think we have another question about technologies, and we can bring that one up. Let's see. All right. Have people taken the first poll? And then we can bring the next one up. I'm not sure if I'm seeing the right thing. Ah, yes, you scroll down and you see the technology one. All right, they're in the same poll. So go ahead and take those. And then when that is done, I will turn it over to Sarah to get us started.
All right. Should I go ahead, Elise?
I think you should. Yeah.
Okay, great. Yeah, sorry about my windows here. I'm just trying to make sure I can see everything all at once, which is a lot to ask, apparently. So yes, I'm Sarah Toth-Kotwis. I'm a Senior Associate at RMI. And we really wanted to develop a resource that builds on all the great resources that our industry has released, that ACOR in coordination with WATT has put out recently. And yeah, it seems like we just got our poll results, lots of engineers, utility representation, some vendors, some nonprofits, and others. and a lot of interest in all of the above of these technologies, especially high performance conductors and dynamic line ratings. So that's great. We're going to cover all of that today. And so, yeah, we really want to build and be additive to all of the great reports on this subject that our industry has released. So we wanted to work with Quanta to develop a planning guide, because we saw a gap in how, despite all the many benefits that ATTs have been shown to provide, they continue to be viewed as operation only or niche tools, and they aren't considered as a matter of course in planning paradigms. So the way that we see it is that these alternative transmission technologies, or advanced transmission technologies, are a complementary and important piece of the overall puzzle when it comes to holistic transmission planning. So you can see on this little graphic here how we have deployment timeline on the x-axis that increases as you go to the right, and cost or resource intensiveness as on the y-axis as you increase up. And so we really see advanced transmission technologies as this short-term bucket where it helps make the most out of the existing grid that we have today. So it's very quick to deploy and it's cost efficient. So these are the three main grid enhancing technologies that we'll talk about today: dynamic line ratings, advanced power flow controllers, and topology optimization, as well as high performance conductors. So in combination, those four things we refer to as alternative transmission technologies or advanced transmission technologies, or ATTs. And that's very complementary to what we also need to do to build the 21st century grid, which is rebuild transmission lines, build new transmission along existing rights of way. Those are kind of fall into a medium term category. And then in the long term, build new greenfield transmission lines and have an interregional macro grid. Though all of that takes a lot more time and money and planning involved. So focusing back to ATTs, what are we really talking about here? And I wanted to give an at a glance high level overview of these four technologies. So dynamic line ratings, sometimes transit analogies are useful in helping understand what these do. And it's kind of like real-time adjusted speed limits, where if you have a sunny, perfect day, you might be able to go a little bit faster on a road than you would in inclement weather conditions. And so similarly, dynamic line ratings allow to adjust the carrying capacity of transmission lines based on the real-time weather measurements. So we can get more out of our lines when the conditions are right. Power flow controllers, the analogy here is kind of like railroad switching stations that direct trains onto free tracks. So they can push and pull power away from overloaded lines and onto nearby lines with spare capacity. Topology optimization is kind of similar in function to power flow controllers, but is an exclusively software-based solution. So this is kind of like Waze, but for the grid, how they're able to reroute drivers around traffic. You can redistribute the power flows across the transmission system based off of what an algorithm finds to be the optimal path. Then finally, we have high performance conductors. So this is kind of like if you have an existing highway, being able to widen that highway and allow more throughput. So that utilizes the latest in high temperature, low sag composite conductor technologies to dramatically increase the carrying capacity of transmission lines in place. So this is the high level overview. And yeah, like I said, Quanta is experts in transmission, interconnection, integrated resource planning, and they're going to help bridge the gap between operations and planning to provide guidance on how to incorporate all these technologies into these planning paradigms. So with that, I'll hand it over to Rahul.
Perfect. No, thank you, Sarah. Okay, so good morning, good afternoon, everyone, and thank you for joining us today. My name is Rahul Anupkumar, and I'm with Quanta Technology, serving as an advanced director of the Advanced Transmission Solutions Group. I'm really excited to walk you folks through the Advanced Transmission Technologies planning guide that we put together. This document is really designed for stakeholders to navigate the integration of some of these innovative transmission solutions amidst all of the grid's evolving challenges. So we'll cover the why, the how, and try to provide about actionable recommendations. Now, one of the most interesting tasks of this week for Sarah and I was to really compress that 50 plus page report into a 15-minute, 9-minute, 9-slide kind of slide deck. So I think what that means is, definitely encourage you folks to go out there, read the report very closely, ask us more questions. We're always around to help. With that being said, Sarah, if we could move on to the next slide, please. Thank you so much. Okay, so really starting with the big picture, right? So everybody knows the US electric grid is under pressure. We're seeing explosive demand growth from electrification, large loads, data centers, a resurgence really in manufacturing as well. All of this while generation interconnections are slowly trying to keep pace with this. Now, the result of all of this is really what we talk about as congestion, reliability risks, delayed clean energy transitions. Now, to address all of this, we really recommend a more balanced strategy, which is pairing traditional transmission expansions like line substations with more of the advanced transmission technologies or ATTs. These aren't really pie-in-the-sky ideas. They're kind of tools that are out there to unlock capacity without the full cost and timeline that you're traditionally used to with other greenfield builds. And so on a use case by use case basis, there are appropriate triggers that can be made leveraging these technologies. Now, the key ATTs or advanced transmission technologies that we focus on include grid enhancing technologies, which are really things like dynamic line ratings for like real-time ampacity boosts, advanced power flow controls to really steer power where it's needed, and topology optimization to really reconfigure the grid. Now, for longer term plays or mid-term, however you want to think of it, advanced conductors as well, like the high temperature, low sag lines, allow us to upgrade kind of existing transmission infrastructure, and in some cases without new right-of-ways or towers being built. Now, this guide really lays out practical methodologies to weave all these ATTs into our core processes, which include your transmission planning, your interconnection studies, and even your integrated resource plan. What we've tried to do is align all of that with FERC Orders 2023 and 1920, touch on operational must-have, and share real-world case studies demonstrating where there are cost savings and also a lot of massive capacity clearance. So now we'll quickly zoom into the planning landscape. If you could go to the next slide, please. So on slide 3, we're really tackling the first question that everybody asks, which is why ATTs, right? So simply put, these technologies are useful for let's say 4 reasons now. One, they expand the transfer capability on existing lines, think 20-30% more throughput. They slash congestion costs, which actually topped around 10 billion last year alone. They also accelerate renewable integration, if you think, and there's a nuance here around whether it's an energy-only resource versus a network resource, which I'm sure Sarah can talk about as well. But they also help benefit the interconnection of large loads, right? And there are a lot of demonstration projects that are out there on that use case. And fourth, they really boost the system resilience and flexibility, like Elise had pointed to earlier, when you're talking about extreme weather as well as other outages in the system. Now, gets shine for like operational and short-term wins. They very smartly leverage what you've already got, targeting those kind of nagging bottlenecks. Advanced conductors, on the other hand, increase the ampacity via reconductoring with high-performance materials. Now, when you think about the RTO and ISO planning horizons, and keep in mind again that there are a lot of specifics to it, we're really trying to generalize it here so that it more broadly becomes applicable outside ISO RTO regions as well. So you have short to midterm planning focuses on reliability and let's say economics, right? You must have all heard of needing a 1.25 benefit to cost ratio. You've also heard of public policy drivers, which are really over a 10 and 20-year horizon. And there's this long-term view from Order 1920 as well, which really requires, I would say now, more capacity expansion modeling as well, with deep reliability and economic dives, really looking out furthermore beyond the 10-year horizon to find the least cost generation mix. And so the question is, where do you really think ATTs could fit and how we'll see all of that play out? And that's really what we're going to try and break down at a high level, at least in the next few slides. But we've tried to go into a lot of depth of discussion within the reports. If you could move to the next slide, please, Sarah. So continuing on this slide, just connecting the dots to different planning cycles, right? So we know interconnection studies are very critical. They ensure that new generators, large loads, they don't jeopardize our reliability. And what can ATTs do, really serving as cost-effective network upgrades where applicable again, often faster and cheaper than the traditional fixes. And again, this whole construct of whether it's an energy-only resource versus a capacity resource. There are examples of technologies like smart wires helping or benefiting, addressing stability concerns in the system and helping generators interconnect sooner. So there are all of these examples that we have out there. Now, for utilities that are doing integrated resource plans, there's really an opportunity to blend ATTs into both generation and transmission strategies. Now, there are modeling challenges that persist because most of the IRP tools really are more zonal in nature and don't really fully capture dynamic power flows. So one of the things that becomes a common theme is that to really make all of this work, we need a lot of strong integration. So cross-team kind of coordination between planners, operators, adoption of more probabilistic scenario-based modeling to handle any kind of variability that ATTs bring to the table. Traditionally, as a planner, you are trying to get a good handle on any kind of variability and really plan the grid for that. So you want any kind of solution that you propose to be least regrets and serve multiple needs. So think of kind of ATT in that framework. Also very important is proactive stakeholder engagement to align with all of the regulations. These are all really not just nice to haves. I think what we begin to see is to really benefit the broader adoption and the way people think about these technologies. It's important for all of these to be coordinated and work hand in hand. Now, over the next few slides, we'll really try to go into each of these processes a little bit more step by step, starting with some regional transmission planning. If you don't mind, Sarah, moving to the next slide. Okay, great. So, so thinking about regional transmission planning as well, we map out the entire planning process, simplifying it. Let me say oversimplifying it into really 4-step cycles. More details in the report. Step 1, let's say identify drivers, right? You have short-term, medium-term planning, which revolves around like 3 pillars. Let's just say reliability to meet your NERC standards, economic analysis, where you're targeting the 1.25 benefit to cost ratio projects. And you've also got the public policy projects, which are your federal, state, or local mandates. And how would you achieve those? For the long haul of Order 1920, it's about capacity expansion modeling to meet a least cost future generation mix. This is where you kind of try to baseline all of your needs and spot the ATT opportunity. Right? We're used to seeing open solicitation windows where processes vary. Certain ISOs use a sponsorship model where the bidders propose solutions to address needs. In other cases, the solutions are already identified. And so you're really bidding on the solution. And so either way, it's really an opportunity for both the ISOs, RTOs, as well as folks that are bidding or proposing solutions to address needs to really start thinking about ATTs. Now, when you go into selecting the right solution, your criteria weights things like cost, constructability, and much more. And Order 1920, as we know, mandates quantifying 7 benefits, including production cost savings, reliability boosts, reduced congestion. And ATTs have played a role over here when they're either pre-identified or bidder proposed. And the way to integrate these, we are beginning to see that tools are evolving as well to really be able to provide you with the flexibility to understand what kind of ATT technology addresses a need in the system. But it's also important to recognize that all that has to be supported by the way you traditionally think about planning for uncertainty, right? You want a high, a medium, a low, an average. You want all those statistics. You want that information to help drive anything that you do in the planning space. Now, step 4 is really where you build the projects and you factor in the execution time, depending on whether you have a short-term need versus a long-term need, whether the long-term need requires the transmission expansion to be there. Can you temporarily place gets to kind of delay till you can get all of the construction activities in place? There are different ways to think about it. So long story short, a lot of optimization is really needed in the planning space, not being limited to, hey, can this ATT technology replace another technology? Because that, just given all of the stress that we're seeing in the grid, we need to look for what the short wins are with ATT and how you can benefit from operational flexibility and all of that as you even consider the design of these longer term and greenfield projects, which are absolutely necessary. If you could move on to the next slide, please. This is again the interconnection study process. And this is another hotspot as well for ATTs. You've seen a lot of discussion out there about what ATTs can do in the interconnection space. This 4-phase kind of approach that we kind of have over here. Step 1 is really, you have an application window, generators submit the requests, and all the generators that are in the same cycle get studied together as a cluster. And then step 2, there's an impact study that's performed. and you understand the cluster effects, looking at snapshots of thermal voltage stability and the peak light load, and all of the different NERC and local planning criteria contingencies that the utility has. The violations, of course, trigger network upgrades. And here's where you can look at what ATTs can really do. Now, whether you are an NRIS project or whether you're an ERIS project, I'd say the construct of what an ATT can do for you differs a little bit, and we've gone into the details of this in the report. But ultimately, there are use cases for different ATTs that need to be evaluated. And given where we are at right now, where generation is falling short and the needs are kind of rising at a faster rate, there's definitely an important need to start considering these different ways that you can think of ATTs in the interconnection planning space. It all goes down to step 3, which is a facility studies, where really all of the facilities to interconnect the project are really defined. And step 4 is where the generator interconnection agreement, or what everybody knows as the LGIA, is really drafted. You kind of negotiate with the generator, the operators, as well as the owners, the different participant funding mechanisms where sometimes the customer foots the bill and the GIA is signed and construction kicks off. And going back to the point I made earlier, it's really about how do you optimize ATTs across all the different use cases. If it's absolutely sure that a line is needed for NRIS benefits, till that line is in service, what can you achieve with an ATT? Or what can the ATT do in the long term that you might not need that long? So these are different ways that you need to optimize and think about it. And so it's not a one-stop solution that solves everything. Now, the most interesting one, if you can go to the next slide, please, Sarah, is in the integrated resource planning space. And thinking about a 5-step holistic approach here, and this one is really a more coordinated planning process that is really thought of more holistically or from a 100-feet view, and really doesn't go down to the depth of detail that you've seen with other planning studies where you are working with power flow models and production cost models and all of that. So in step 1, you're really defining the system that you need to study and identifying the needs. So you're setting the assumptions on transfer capability, interconnection speed of generation, and the forecasted demand against your portfolio. You really need to think about leveraging ATT experts at this point in time to tell you how your assumptions are going to be modified to reflect the impact of any ATT technology, right? So if the ATTs are going to allow you to interconnect sooner or energize a project faster, you factor that in because those are traditionally constraints in your capacity expansion model. So you need to think about how these technologies affect each and every constraint. And then in step 2, you develop the resource portfolios. You identify solutions like new generation, demand response, and these capacity expansion models get you the least cost mixes. You also try to factor in, when you're thinking about inter-area exchanges, what can ATTs do to some of the tie lines? And so to the extent that you can benefit from building generation in a lower cost zone, and then taking advantage of what technologies do to tie lines to basically wheel that to the other region, you can factor some of those things in. Now, in step 3, you're really conducting an economic analysis or an economic modeling where you're running detailed production simulation studies, hourly markets, assessing cost benefits, really trying to reflect everything that the ATT enables you to change. And you can factor in things like how much of congestion is changing and what are some of the violations that are being addressed here. Now, step 4 is generally when you do look at your portfolio's reliability, you stress test against weather, outage conditions, and you try to quantify how certain ATTs can basically enhance resilience, which is something that we spoke about earlier as well. Flexibility is, of course, a key aspect of everything that we're going to do to plan the next generation of algorithm. Now, then step 5 is really where you procure the resources after you've gone through this whole process. So IRP is where really a lot of the co-optimization happens. The ATTs are kind of complementing your capacity. They're also reshaping your entire resource stack for more efficiency. So that's how you should think about the ATTs in this horizon. You can move on to the next slide, please, Sarah. Excellent. So just this is the last slide that we have here, and I'm going to hand it off to Sarah as well to make a few comments. Because I just went through this very quickly, didn't give her a chance to comment. And I just wanted to say that some of our key recommendations to put all this into action is to really integrate transmission, generation, and to a large extent distribution for a true co-optimization, right? I think the siloed approaches kind of miss the synergies. And as much as, you think that that's a bigger problem to solve, it is becoming a key theme in how you are able to think about how ATTs technologies can provide you guys benefits beyond what you're traditionally used to thinking of. And okay, hey, I'm just going to kind of deploy a DLR on this line versus something else. The whole integrated approach to how multiple ATTs work together and how you can benefit one from the other or trade one off the other, those aspects end up missing unless there are synergies in planning. Now, embracing portfolio and scenario-based modeling to capture the ATT variability is one of the ways to think about how you could bring these technologies and you think of them in their planning horizon. What you're also doing through this artificially is really enabling the collaboration between planning and ops teams. And that's ideally what you need at the front line, right? Because we are talking about technologies that everybody is used to thinking of as being more operational, and rightfully so. But how do you get a planner to think about those operational technologies? It's almost like you're asking a planner to do operations plan, right? And these I think are just advantages of bringing that collaboration and making it happen. I'd also say that we have been in discussion with a lot of the advanced technology software companies, and there's a lot of work being done with tools to really more accurately simulate the impacts of these ATTs. Optimizers are evolving, the ability of loading in kind of that stochastic data and probabilistic data that we spoke about to really look at the impacts of these different technologies are also significantly improving. Now, I think another aspect of it is definitely for stakeholders to develop and adopt an ATT integration standard and guideline to really standardize rollout. That's why I'm very excited to hear about what David has to say as well, because they've been very, very successful in kind of deploying the DLR technology at scale. Now, ensure that there's a real-time adaptability to all of your designs and continuously monitor and evaluate performance with a lot of data analytics, right? Like if you think about a technology like topology optimization, a question you should ask yourself is, okay, I know if I'm planning for the grid of the future, how do I design my substation such that when I get to near real time and operations, I can take advantage of topology optimization as a technology much more readily. So how do I enable these technologies from the planning framework? So that's how you would want to think about it. Also, and most importantly, engage all the stakeholders for alignment with policy, regulation, and because FERC is watching, right? We know that. We saw 1920, we saw Order 2023 definitely being watched, and that's great. Sarah, this is the last slide that I had. Anything you'd like to please add? Yeah, sorry, I didn't. I just went on there.
Yes, no, that was great. Rahul, you captured it all really, really well. And I think the point is that ATTs aren't a pie in the sky idea anymore. We have practical approaches to consider these technologies in planning paradigms now. And so with this new guide, everyone can gain the understanding necessary to know what does a rigorous application and assessment of these technologies into planning look like, rather than a box checking exercise. And furthermore, there are some leading utilities that have already applied these methodologies and benefited from their applications of ATTs. So that's what I would love to hand it over to David now from PPL Electric Utilities to share a little bit more about that.
Yeah, sure. At PPL, we definitely believe in using advanced technologies on the grid, and Raul did such a nice job really kind of summarizing a lot of those technologies and how they can integrate and how we operate and how we plan and how we interconnect. Just as kind of like our foremost use case, at least for us, has been dynamic line ratings. And this timeline, just to kind of speak from it a little bit, and I know it's a little busy or simplistic, but what I like to highlight here is, it was in June 2020, there was going to be, it was really 2 transmission lines, but one of them had multiple segments. So we can say 3 lines that were going to show up with congestion on them in an upcoming PJM market efficiency window, which then spurns an open window of competition, and it typically burns more transmission infrastructure. And we felt like, they may be good use cases for dynamic line ratings to see if it could solve it. And so from the time we made that decision in June, it was December of the same year, so about 6 months from the time we thought about it to the time there were actually sensors up on the lines. So it kind of shows like those first 2 dots of that timeline, pretty easy. Like working with the vendor, placing the order, getting them up in the air, they can be installed live. It took about 15 minutes per sensor, like literally. But then if you look from from Q4 2020 to Q3 2022, that's 2 years then it took to actually get it in the day ahead market. And in PJM, where it was actually saving costs for customers. The lessons learned there, and I'll say the gold in that is that the lessons for us was, if you really want to reap the customer benefits, you have to make sure that you pull the thread all the way through. PJM was an excellent partner for this, and ISO New England has shown themselves to be the same in Rhode Island so far, in that there's the initial benefits to customers in that. If I go back to the market efficiency window, one of the lines, it's called the Harwood Susquehanna line, would have needed a almost $60 million rebuild project in order to resolve the congestion. The dynamic line rating sensors were about 250 grand. And so the benefit to cost ratio isn't even, you know, a conversation. It's a no-brainer if dynamic line ratings works to alleviate the congestion. But the other savings for customers isn't just the deferral or the elimination of the transmission projects, it's also in the congestion costs. For that original installation, PJM estimated that we were saving customers $23 million a year in congestion costs, and that's just ongoing. And so that kind of gave us the incentive to just really keep this going. So now we have it on 10 transmission lines in Pennsylvania, all at 230 kV. In Rhode Island, we have it on 3, but we did 3 different voltage levels to learn differently from. So it's at 1 at 345, 1 at 115, and 1 at 34 kV, which is actually more distribution. And so we're really kind of just like absorbing the data and information from these installations. But I think what I'd say is, on the back half of that timeline that is shown, you know, we ourselves, when we were going through, like, well, how are we going to comply with certain compliance standards like FACO 08 and some of the SIP standards? What happens if we're going to depend on this data for how we operate the transmission grid? What happens if there's a gust of wind that's 50 miles an hour and then it goes right back down to 15 miles an hour? What happens if we lose communication? How are we going to integrate it into PJM's day ahead market if we're getting the data? And when you kind of go through each of those issues, I think for us, like, we expected it to be harder than it was. And there were entities that really helped us through it. Like, we roll up to Reliability First for NERC compliance. Reliability First did what they call an assist visit with us to kind of help us through those standards, and even kind of sharing, like, when we audit you, we'll kind of like take some of this into account when we're looking at those specific lines. PJM was great. We actually had a weekly, it was a Monday afternoon call with PJM. Every Monday we met with them, working through all the issues. And underestimated on my part was a lot of the issues integrating between the utility and the RTO were actually on the IT end. Like, you know, we typically give our static ratings in the past to PJM for a line. It's in our model, it goes in their model, it's set. Now it was changing to every 5 minutes. Our operating system is updating a rating, and every 5 minutes so is PJM's. So now we needed a link between our operating systems. So we had to build an API that acted as that bridge, so that we were now exchanging ratings information. But now, once that was all set up, which was basically that 2 years between Q4 2020 and Q3 2022, every other installation has just been easy. You know, it's not 2 years until it plugs into the market. It just, now it's kind of like the pathway is cleared. And so I just share this in that I think to some degree, it's like all of the advanced technologies have those wrinkles of, like, it's kind of, you know, there's the initial vision of how it's going to work. Then there's the devils in the details, but not letting those little devils stop us, but just kind of like continuing to work through them. And in the end, like, we're all kind of industry teammates, and so we can kind of all work through it all together. But thank you.
Okay, so
Awesome.
yeah, we're going to go to Julia now for her reaction.
Great. Well, I'll just echo all the other panelists and say thank you for coming today. Really exciting to hear this structural idea for how to include grid enhancing technologies in transmission planning, and then David's examples of how it worked out in the real world. And I think the lessons I take from all of this are that GETs and high performance conductors can be considered in transmission planning today. They can be used by utilities and certainly integrated into the day-ahead market in PJM. That is a real achievement that PPL did the legwork for any of our other colleagues in the PJM region. I think the FERC Orders 881 on line ratings 2023 on generator interconnection and 1920 on transmission planning mean that these technologies are expected to be in the toolbox for utilities. In addition to those that have been brought up already on this webinar, about 15 states have passed legislation requiring GETs in some context associated with state authority over resources or other authorities. But often those laws have even more specific timelines and expectations in place than FERC has given. And so we expect an acceleration of all of this across the industry, and excited to see this as a starting point. In addition, there are so many industry partners who want to help. The WAC Coalition is the trade association for vendors for grid enhancing technologies. We also have utility and generator members who are advocates and learning about these technologies. There are user groups at the Energy Systems Integration Group and the Electric Power Research Institute. Department of Energy has technical assistance for compliance with Order number 1920 that states and utilities and RTOs can all leverage for these technologies. And then, of course, there's the vendors, and there's folks like Rahul who can help with the analysis in Plexos and in the software that utilities use to evaluate how to solve their grid constraints. And then I'll quickly answer one of the questions in the chat is about the financial incentives that utilities have to deploy these technologies or not, right? The general business model for utilities is that you build capital infrastructure and you make a rate of return off of the infrastructure that you build. We do see this as a real obstacle, and for the past 5 years it has been. I think looking forward with the amount of load growth that's expected on the system, we see utilities more and more trying to manage the pace of grid expansion, and their ATTs have a real value to the utilities' bottom line in terms of interconnecting new customers and serving those customers. But I don't want to understate that obstacle still exists, especially in generator interconnection. I know there are a lot of generators on the phone today. The utilities provide generator interconnection studies and don't always consider GETs at this stage. I put in an example in the Q&A box of different projects that generators have asked for GETs to be studied in, and we hope that becomes much more common, but definitely need more advocacy and more education around those opportunities. And I'll leave it at that for now, and excited for more Q&A and discussion. Thanks all.
Great, thanks everyone. I know our all-star team of panelists has been hard at work typing a number of answers to your questions, but please post any additional questions that you have in the Q&A function, and we can also get to those live. But I will tee up a few questions right now as you are pondering additional questions or anything you want to see addressed that wasn't addressed by any of the panelists. So, one thing I wanted to go back to a couple of questions. I'll start maybe with Sarah. I was wondering, given that we have the great presentation, really helpful to have David from PPL talk about what they are doing actually on the ground. I was wondering if there's any other, and other panelists can answer this as well, but we'll start with Sarah. Any positive trends you've seen in recent years? Any other examples that you may want to highlight of how ATTs have been incorporated into any of these three fora?
Yeah, absolutely. Yeah, like Julia mentioned too, there are a lot of states thinking and promulgating policies and regulations based on alternative transmission technologies. So that's a great way to get over like some of the hurdles that utilities might experience with these devices being really low cost, but having like a bit of a learning curve, as David was mentioning, to deploy. So states have kind of taken up the mantle on that and are starting to, write that regulation and policy to help encourage utilities to consider these technologies. And then beyond that, we're also seeing some like good deployments of these technologies. So PJM, I also mentioned this in the chat, but PJM has approved the use of an advanced power flow controller in a generator interconnection application process. So that was a very cool first to see, these technologies being considered in interconnection. That was, a kind of a unique case, and I haven't seen it, done elsewhere yet, but we hope to see more and more of that going forward. So, and then beyond that, I've heard of a lot of different deployments of high performance conductors across the United States and globally, actually. And actually, I think Quanta has recently participated in one of those deployments. So Rahul, I don't know if you want to chime in on Quanta's deployment of advanced conductors.
Sure. I think the only quick comment I'll add there is, yes, so Quanta Services, which is our parent company, is heavily in the whole EPC and construction side. And so then they have been involved with a lot of the deployments that have been discussed in and around Montana and all of the other regions as well. So, yeah.
Okay, great. Another question I have, I'll ask Rahul. I thought it was really interesting because you're pairing like the more technical needs for better modeling with stakeholder engagement as another key provision. So I was kind of curious, especially almost more on the stakeholder engagement side. Do you feel like as you engage, there's misunderstandings about ATTs or anything that you think would be helpful in getting stakeholders to have a better understanding? And then we're going to go to some of the online Q&A in a minute. But
oh yeah, absolutely. No, thanks for that question, Elise. I think, not so much talking about the stakeholder engagement piece, but I think one general misunderstanding that I am hearing, and I think sometimes maybe negatively affects discussions around ATT, is that, nobody's saying that ATTs are going to be replacing the need for new transmission or transmission expansion. And I somehow feel like that, narrative hurts the technology's adoption a lot more. Even though, you'd think that, okay, we just go and deploy it, right? And you defer transmission. It doesn't really work like that. I think between like Julie, Sarah, and David and all that, we've looked at so many use cases and it doesn't fit everywhere. So what we are saying is there is a right use case for it. Give it a chance, right? And like investigate it. And, and I think a lot of people are actually doing that. I credit where it's due. We've been in discussions with utilities and we can look at CalISO's plans. They are thinking about ATT technology and evaluating it. I think so I think a more broader misunderstanding that nobody's looking at it, I think even that is false because people are considering it. Now the question is, are they considering it for things like, can we advance interconnection queue, can we kind of interconnect load sooner and all of that? Again, on a case-by-case basis, maybe it makes sense, maybe it doesn't, but we need to give it a chance to kind of evaluate and look. And I think we are headed there. So I don't know if that answered the question, Elise. I just spiraled out of control about misunderstandings, but I think, that's kind of what I see as the bigger thing, right? And it's really a double-edged sword. From one place, we're kind of saying that, hey, there is a benefit here. But then we're also trying to say that, hey, it's not going to replace transmission. Nobody is saying that, right? And so it's really something that I think is doing a lot of kind of harm to us in a way. Yeah, I don't know, Julie, any thoughts on that?
Oh, sorry. I was also just going to jump in with another thing that we hear is like, oh, well, we investigated this 10 years ago and it didn't like apply at that time. Well, a lot can change, especially in our industry right now in terms of like power. So really, and technologies too, technologies change so fast and they're always improving. So the dynamic line ratings of 10 years ago are not the same as all the myriad of different offerings of dynamic line ratings today, and the same for all sorts of other technologies. So it's perhaps time for some of those utilities who may have considered it and written it off many years ago. Let's try and get updated with what's the latest on what could be provided and how, and see whether that could fit into today's needs.
Yeah, I agree with all those points. And I'll say, as much as, it's already more homework to look at grid enhancing technologies in these situations. So we appreciate that we are asking more of utilities today, but I think we need them to do even a little more work and share their findings of these studies. And really appreciate, David getting out there and explaining how PPL did their work and how they expanded it and what results they saw. That's the kind of thing that makes it possible for other utilities to follow suit and for those studies to be successful, right? Because if those aren't available, a utility could, say, well, DLR could give us 5% more capacity or could give us 40%. There's no way for me to analyze this. That's our analysis, right? And so we're really asking for more these days. And I think the tools are out there, but it's about forging those connections and sharing the information.
Okay, great. Super helpful. I'm going to go to some of the questions. Quick logistical note. Somebody asked about the chat. Just use the Q&A function. We're not using the chat for questions. So just a little logistical note. So another question was about superconductors. Can those be included in the high performance conductor category? Are they still considered? We think they are. I want to hear from the panelists. Anyone who wants to comment on superconductors?
Yeah, my colleagues at Grid Strategies administer the AMP Coalition as well, which is the Trade Association for High Performance Conductors, and that's composite core conductors and superconductors. So absolutely working on making sure that those technologies are evaluated appropriately, and that folks are aware of what's out there.
I just quickly second that as well. And yeah, I completely agree with Julia. And, I see, and maybe I'm jumping ahead here, Elise, but I see another question as well, which is a common question that I'm hearing a lot about. Like, is there any kind of guidance on how do you select the right advanced conductor or, like technology, right? I mean, like it doubles the ratings, it reduces the impedance by 20%. Some kind, maybe initially information of that nature is sufficient from a planning perspective. I think that is something that is still kind of missing, in all honesty. And I think you do have to go down the rabbit hole of contacting the vendor and kind of getting that data. But trust me, there's a lot of benefit to that because you do end up learning a lot more about the technology and not just that, the same conductor is going to reduce the impedance by 15% and double your capacity. Any other comments from anyone? David, I know you're up in this
Yeah.
space.
No, agree. I think I'll say like we started to use conductors from our former standard that are about 20% higher capacity. And we're constantly evaluating the ones that lifted even more, just like you said, Aro, like almost like twice the value. What we run into sometimes with vendors on the vendor side is we'll have concerns about the ice loading of it, or we'll have like deeper questions. And then we'll have promises, but then when we go into terms like, okay, well, can you include that in the warranty? We want to jump in on this, but like, this isn't just like DLR, this like low expensive sensor. This is like a large project, and we're looking for a little bit more on the vendor side for the more cutting edge technologies when the price is much higher, out of protection for our customers. But as the conductor and capacity ratings continue to rise, there's also the potential to link the two technologies together to really get lift, where you have like higher capacity conductor and dynamic line ratings and other technologies and kind of like compounding the benefits.
Mm-hmm. Yeah, I appreciate all those comments. And I'll just say also that Portland General Electric I think has or at least has shared with us that their method is to analyze all available conductors for any time that they're choosing a conductor. And that's really, I think, all that the industry is asking for. I understand utilities are looking for some more things from vendors, which is good to hear that those conversations are happening. But yeah, as Raul said, these technologies don't apply everywhere. And there's a broad range, especially on the conductor side and also on the DLR side. I think EPRI found like 30 global vendors for DLR. So for better or worse, utilities get to choose exactly what fits their needs. And I think a robust and competitive market for all these technologies benefits everyone. I will say on the conductor side, why did I open this box of worms? But there's really a gradation of different technologies that offer different benefits and different price points. So we work mostly on the technologies where we see a sort of policy level obstacle at Grid Strategies to deployment, but we are seeing a shift throughout the industry where technologies like ACSS, which is aluminum conductor steel supported, so stronger steel and more conductive aluminum, are becoming the default for some utilities, and we think that's really great. And so the question is, can we make sure that all of the advanced technologies that have been available for decades, in some cases, are considered in project development?
Okay, great. A bunch of questions now. One of them, some I think I can group together, but one of them is diving a little bit back into the interconnection process and really how both the interconnection customer developers, how the large loads can ensure that gets are incorporated into the study phase in lieu of any required expensive transmission upgrades. I don't know if anybody had any further thoughts on that question.
Yeah, I would say at this point, I definitely encourage the developer, whether you're developing a generator or a new large load, to communicate in advance with the utility or regional transmission operator that you're interested in assessing grid enhancing technologies and all alternative transmission technologies to see if they can help get your new load online or generation online faster. And then, and anyway, because of FERC Order 2023 and 1920, those operators and utilities should be considering them anyway, but it kind of opens up an avenue for collaboration between that developer and the utility. So we can really talk about, hey, what sorts of interconnection service makes sense for you, and what are the technologies that can be enablers of that, and vice versa. So yeah, I would say like open that line of communication, make it known that you're interested in that, and it should be well received.
Yeah, I think the not very satisfying answer is just keep asking, because a utility might think, well, it's not worth, I'm sorry, I'm speaking for utilities so much, David, but they might think it's not worth updating our systems and training our staff just for this one customer who wants this specialized technology. But if they've heard it 5 times, 10 times, if they've heard it from their generators and their loads and their regulators, and FERC and the legislators, I think at that point it becomes clear that that investment is prudent. And I, as a ratepayer, wouldn't necessarily want my utility evaluating any technology that anyone brought up to them. I think these technologies, and then that's part of why the technology categories are important. These technologies have been around for years. They've been proven out around the world. Somebody asked about momentum on implementing ATTs across vertically integrated utilities specifically, but there is real momentum in the United States and abroad for these technologies. These are not science projects; they're commercially available. So I'll point you to the WATT website for those examples of solutions and other vendor websites. But all right, I believe I've answered the question.
No, and maybe I'll complement that real briefly by saying, like, using like technology like dynamic line ratings for interconnections is like a holy grail because it's fast and it's inexpensive. We're really looking to make that work. One of our challenges we're facing right now is when you get close to the customer, especially at lower voltage levels, they have their own profile that doesn't always necessarily match the profile of the dynamic line rating. So it gets easier when you aggregate it up to like a higher voltage level on the grid and you apply it at that level. But as maybe the technology gets better or we get smarter with it, we can get it down to a more granular level. But that's the current challenge, at least for us right now.
Just one last thing to add to this. I know we've been spending too much time on this, but this is a critical topic. I mean, quite honestly, being on kind of the other side of things as well, I am seeing that, especially when some of the utilities, ISOs, they put their models out there, they ask developers to review their models, they do all of that, and then they give you these reports saying these are some of the violations. If you are able to work to show how some of these technologies are actually helping solve the problem, right? I am beginning to see more and more that they are willing to listen. And if the use case is right, then there is consideration for it. I think the PJM comment example that Sarah brought, the PJM interconnection example that Sarah brought up earlier is really a great use case and example of that, where I think smart wires was used to address a stability problem. instead of, I think, building a new transmission line or something like that. Sarah, I could be wrong here, but I think that's really great that that's happening. So the only thing I'd say is same thing everybody's saying, definitely keep talking, but also do your homework, right? They're trying as much as they can, making the models public for you, giving you tools to run it. Do your homework, show that the use case works so that you reduce the burden on them and you make a more convincing case for yourself. Yeah. Thanks.
All right, we have a few more minutes, but maybe I'll just grab the next two questions, see if we have any answers to those. I know this has been talked about a lot, but if anybody wants to talk more about the regulatory accounting treatment of these technologies, I know there's differences whether it's a GETS or whether it's advanced conductors. Also, I've been hearing this question a lot lately, but how you look at this on the distribution side and what opportunities are there. I know there are opportunities, but anyone wants to take either of those two questions before we wrap up?
I'll say real quick, for us, it's like a different basket of gets to some degree on the distribution side, but there's definitely gets that applies to it. Whether it's a version of dynamic line ratings or even other technologies to try to predict faults before they occur so that you can prevent outages or reduce O&M costs, like to reduce costs for customers. So there's definitely applications for gets on distribution. Our take is that it's just kind of like a different tool set of gets than it may be for like higher voltages.
Yeah, one important thing on the distribution grid versus transmission is the transmission grid is very intensively studied and understood, and the infrastructure is very big and expensive and serves a lot of customers. So that means it's both clear where there's a need for investment or for expansion, and the costs that you avoid by deploying gets are very high compared to the ones on the distribution grid. So definitely the like quick big wins are at the transmission level. I won't get into too much detail because we don't have time, but yeah, happy to follow up.
Just one quick comment, if you don't mind, Lisa. I know we're almost up on time, which is that, and the distribution system as well, to the point Julia made, is predominantly radial. It's not really meshed unless you try to mesh it and move loads from one part of the system to the other. So that's a completely different characteristic that warrants, like David said, a different kind of gets. Right? So that's just something to highlight. Thanks.
Great point.
Okay, well, we're at 2:59, so we're not going to start another question. I just really want to thank these panelists. This is a fantastic discussion. I think the number of participants shows the enthusiasm for the topic. So we will follow up with the slides, the recordings. Please reach out to any of us if you want to continue the dialogue, have any questions, and just really appreciate everyone attending today.